Hello and welcome back. In previous videos we initialized our main loop, we made our shell loop, we get the input from the terminal using getLine, we pass the input into arguments, and now we are calling the shell builds that we planned earlier. As you know, we already implemented cd, pwd, echo, env functions. Of course, we also have accident create, which isn't a function, but it's a command built in, so it's working nice. In this video, we will make our which function, and we will create some custom functions and implementations to make it work. So let's talk about which. What does which do? So if you Google, it says the which command allows users to search the list of the pets in the pet environment variable. So we know that we can access our environment variables and we can access the pet. So when we say which, for example, ls, it will reach the environment pets, find the location, and check for the binary ls command in that file path. Or we can try which cd or which echo, user bin echo. So basically what we need to do in the which command, we need to find where is the path for the asked argument. We will need an argument after calling the which. If arg equals null, it's arg1 equals null, which means we do not have an argument given. We will printf. Let's check how was it in the cd. We want to have similar. Which expected argument. Let's give it an extra. I will just say which expected argument, and we can return 1 for showing errors. So as you know, we are making implementations are for built-ins. So if someone asks for which cd or echo or pwd, we know where it's come from. So we know which one is it. It's our built-in comments. So we will have a list of the built-ins, and we will have a constant list of our buildings, constant char built in comments, and they will be the list we created before. Will be cd, pwd, echo, env, setenv, unsetenv, which, and exit. What's the problem? I don't see the problem actually. Yep, this was the problem. Sorry, my bad. I missed it. So we will check if our argument 1 is one of these built-in comments. We will check all the built-in comments. If our argument 1 is one of these built-in comments, it means we know where these are from, and if my strcompare, using custom implementations, if my strcompare args1 is same as one of the built-in comments that we are looping, it will return 0 if they are the same. We want to say printf, that's the argument we are going to talk about, shall build in comment and new line, and we will give it args1, and then we can return 0 saying we successfully completed our loop. So let's try if it will show when we call our built-in comments. I will return here. Return comment which. When we call which in our shell, it will call comment which, and we will check if the command is built in. Let's say make. Of course we have an error, which is env unused parameters. Yes, we haven't used it yet, so let's say void env make another problem. What's the problem? Built-in C non-void function. Let's return 1 if there's a problem. Make my shell. So when we are calling which, it will ask for argument. We will say which, for example, cd. It will say cd is a shell built-in command. Same with others. Let's say env, it will say shell built-in command. So now in our which, we are working built-in command check system. Also, you can declare this in the header file or lex it, and even use an input parser, which I didn't do it, I don't plan to do it, but that's an option. Also in the future, if I want to use this as a global variable, I can declare it in my header and use wherever I need to use. And if it is an external comment, which will be more difficult, check external comments. If it's an external comment, we will need to get the full path. Full path equals, then we will need a helper function, but not in helper.c, only for comment which, that will find the command in path. As I told you before, in our env we have path, and in this path we will check these file locations between two dots, and we will check inside of them to see if that's the location for our, for example, ls or cat. So basically we will check in the path the user bin directory, and then we will open this user bin directory and check if they have what we are looking as binary, ls or cat, and we will find it. So we will need another function to do this because we don't want to keep the which function too long. I will call it find command in path, so it's kind of self-explanatory, I would say. We will give it the argument we are looking for, and of course we will give it the environment we are looking for. And now we don't need to write this anymore. Let's create the function. It will be char star returning function, and it will receive char star nv and char star comment. That will be a constant that will not change, and we will have this function to search for the command in path. This function will search the command in path, and we will find the location. We will have a couple variables to check. Path environment will be null. This will be the path environment we will get from the, we can use setenv probably. We will have char path, again null as initializing. We will have token null, and we will have char full path. We will find the full path. I will call it 124 at the moment. So let's say this will store the path value. This will be duplicate of path. So when we modify the path, we don't want to mess with the environment. We will just use the duplicate, so we will not cause any problems in the future. This will be tokenized this from the path, because we will need to check this singly. And this will be our buffer to construct full paths, which you will see why we need these in soon. So first let's locate the path. For this purpose, I think we can use our setenv function. I will call path env equals get env, which we will give it the name we are looking for. In this case it will be our comment, and the environment we are looking for. My setenv gets char name, and environment we are giving it the comment we are looking for, and environment the path, and we return as our path. And if it turns null, if it's so setenv returns null if there is no path, and if it returns null, we want to return null to saying no path that we can use. So at this part we are getting our environment, we gave it the arguments we are looking for, and we will duplicate the path, avoiding modifying the original paths. I will show why this is important when we are doing setenv and unsetenv. We don't want to mess with the path because we are using pointers, and pointers can cause problems and unintended changes on the original path. So that's why we called path variable before. I will say path str duplicate. Of course we will not use str duplicate, we will make our own version, but we will give it path env. So I will get my strdup, and let's go to helpers and make our own str duplicate. It will return char star my str duplicate, which will receive a constant char star string, and it will return duplicating it. Let's check if str exists. Doesn't exist, we will return null. We will have the length of the str. We have my str length to get the length, and we give it the string. We will malloc it because we need to turn the mallocked version. Let's see, duplicated. It will be char star malloc, which will be len +1 for end of for the last character, and it will be the size of char because this is string char pointer. We will check if it's mallocked correctly, as long as it is not null. If it's null, we will return null, and we will basically strcpy the string to duplicated one. we will have strcpy, and strcpy gets our duplicated with the first value and string, and then we will return the duplicated one. And as you can guess, at this point we will not use strcpy, we will make our own version. Did I already made it? No, not yet. Okay, so let's make my strcpy. And my strcpy will be returning char string my strcpy, which will receive char star destination that we will return, in this case duplicated, and it will have constant char star source that we want to get the data and return the destination. We don't want to play with the original pointer, so we will create a char to return, not return, but let's say that it will be our destinated version, and let's have a while loop while the pointer to the source exists. We will have the destination plus the source, and we will have destination plus plus and source plus plus, and end of the destination will be end of the file, and then we can return that. I made a mistake. We are getting the destination. We are saving the starting address of destination. We are checking the source file, and we are copying the character value from source to destination. We are incrementing destination and source, and we are null terminating the destination string, and we are returning the return. So okay, this should work. Let's go. Let's get back and declare this in our H loop, H function, H file. Okay, my strcpy compare length. Why I forgot that? We might need it later. My str length, my str and compare. My get and me, my str duplicate, and my str copy. So at this point we should have our duplicated path. I think we can quickly check if we have it or not. Let's say printf path equals %s pad and new line. Okay, let's see, make, and of course bunch of problems as always. Implement declaration, we give it the comment and we give it the environment. What's the problem? 98. Okay, first let's say we haven't used the token, so it can stay as void. Used patenv, used pat token, and full pat we also say full pat. Make other problems. Previous simply declaration pat was here. And comment. Oh, yes, we forgot to declare our function before the comment which. I will not declare in the header file because this only needs to work for comment which, so as long as we call it before the which function, it should work. When I say make, here other problem for 100 full pat. For now we can just comment dot make my shell when we say which, for example ls, we have segmentation fault. Interesting. So we know it was working with built-in comments, but when we go for comment, finding the command in the path, we are having seg fault, which ls, and let's find the reason. And we are having seg fault in find command in path function. Let's try to find the problem. I would say we made a big mistake because, not a big mistake, but I can guess the problem now. When we are calling str duplication, we know we use malloc, we call malloc, but when we are done, we are not filling it, so let's start there, free pat. Let's try again, make my shell which ls. Again, segmentation fault, but at least we fixed this problem, because like I said before, my str duplicate returns duplicated. Maybe. Okay, I will find the problem and be back with you in a moment. Alright, after a quick debugging, I noticed I made a mistake on my str duplicate. My str copy works as I intended, but in my str duplicate I am going to, if str equals null, we will return null. Size tlen is strlen, str char duplicated equals char malloc len +1. We are also thinking about the null terminator, and if duplicated equals null, we will return null, and my str copy will duplicate the str. So let's say again, make my shell. Yes, this time my str duplicate works. I made mistake declaring this, so I will clean my main quickly and make my shell which ls and segmentation fault again, and this time why? Let's see. Pet gets my str duplicate and find comment in pet. We are checking if it's null, we are returning null if it's null, we are getting the length of the string, we are mallocing the duplicated version, and if duplicated is null, we are returning null, we are copying str copy, and I would say it should work. My shell which cd which ls. Okay, if you have segmentation fault, all you need to do is put lots of printf statements. This is C language, that's all, the best you can do. So I will call a printf statement finding path that will call comment finding path, and then when we are inside you will say calling get env, and get env will return the environment we are looking for. Maybe before printing that we should check if it's existing. If there's no pet, return null. If there's a pet, it will print the pet of the environment. Then we will have another option saying calling dup, and this should be enough statements. So when I say shell reach cd, this works fine and returns 0. Let's set it again, and we unused void and we make my shell reach ls, and again we have segfault. So our problem was not here. Built-in commands, getting out of the loop. I think I made a mistake here somewhere. As long as we have the built-in commands 4, 5, 6, 7, 8 and 1 empty. 9, I will say less than 9. Maybe there's a problem somewhere here. Make my shell reach ls check fault. So I will not mess with that in this case, because we know it was working fine. If I get something else, it just segfaults. Return 1, main, comment which returns 1, let's say return 1, Marshall which else, again segfault. Okay, I will try to find it myself and tell you what was wrong. Alright, I found the problem. It was my mistake, a simple mistake, because when we are checking my strcompare and we go until the null, the end line, we are not checking for null. That's why we are having segfaults. So same as we did in the other ones, we will do this too, and I will fix all of this. If source is null, it will return null for this case. If get and yeah, we are already checking it. If str and compare, if str1 or str2 equals null, we will return 1, showing there's an error. In my str length, if str is null, we will return -1. In my strcompare, if str1 is null or str2 is null, we will return 1. So I think this should fix the problem, which ls, and again segmentation fault. So even though this didn't fix the problem, I will say this was an important step we had to take care of. And I will continue debugging. I cannot believe I made this mistake. The problem wasn't we were not even checking for null because we were not getting end of this array of strings. So now I add my null. This for loop can successfully loop out of the loop, finding the null command, and then we can continue finding the path. In this case, let's go back to checking if find command in path is getting the path we were looking for. So we don't need to worry this. C make marshal reach ls finding path. Then we are going to find path, calling get nv, which is nice. Path get nv command, we are making a mistake because we are not actually looking for the command. We are looking for path equals, and let's fix it. Make, what's the problem? And turn. We can just read it out. Again, make marshal reach ls and calling get env, and pet env is null. That's interesting, but at least now we are dealing with other problems, not the same problem again and again. And in get env, what we do is we are giving the name and environment, the name it's supposed to look for, and we should return the environment we give, which also we use it in echo. That's interesting. Let's try again. Reach ls. We are calling the get env, pet env returns null. We are duplicating and printing the pet. Of course, it will be null again. I believe we can delete. They can stay for now. Okay, so we need to fix get env having the pet. So I wonder why this doesn't want to work, because because I know that we are supposed to look for pet and equal sign in our environment. Let's say env to a front pet equals we know it exists, and even though it exists, we are returning null. But if we call the same command in echo, it works. So what are we doing different than echo? We are declaring value, we say get env. Maybe instead of like that, we can also say char pot env make my shell reach something and colon get env pet env equals null. Okay, I will do another quick debugging and be back with you. So I just remembered when we are using getEnv, we were also checking for equal sign, and we gave it like this when we were first checking. So I will make a small plan change, and I will make a simple for loop to check what is the environment path we are looking for. I think it will be a simple for loop that we will say for size t int I equals 0, as long as we are in env I plus plus. We will check if my str and compare in iv of I equals path equal that we are looking for. It will have the 1 2 3 4 5 length. We will have the path env equals env I plus 5 and plus 5. There's a mistake here, and the plus 5 will be so we can skip these 5 lines. Skip path, it's called prefix. So we will get the environments and not the equals again. So let's say break, and I will say this time it should work. Make my shell reach ls finding path, calling get env, but it doesn't return, and it breaks out of the loop. So it means we couldn't find the path in env, which is weird. I'm giving the right input for command which we are not even using the command yet, we are only checking env. And let's check if we have the correct environment. I think we had a loop for that before. I will just copy this one and plant here, paste here, I meant. And let's say nv fi. This way we will print, we will see if we are getting the correct nv. That might be the problem, which something, and we have the nv, which is good. Okay. So that means if we have the nv, we should be able to find the path. strcpy gets the string. That's interesting. I feel like I am making a simple mistake and it's quite annoying, but let's check everything again. We know we are getting the correct environment, we don't need to print that. We also don't need to get nv. We locate the path in environment while in nv I plus plus. If str and compare in environment I path 5 equals 0, which means this 5 characters exists in environment I, and path nv equals nvi plus 5, so we are skipping the 5 characters here and we will break out of the loop. And oh, if path eternal, oh my god, I hate simple mistakes. We are basically saying if this is correctly out of the loop, we will return null. Of course we don't want that. If it is null, we will want to return null. I think this was the problem. It's getting quite annoying. ls, and finally we see that we are getting our environment, so we don't need this print statement. We know that we are getting the environment and we are duplicating it. Let's see if we duplicate it correctly. My shell reach something and calling duplication, and this is a duplicated path, which is perfect. We don't need to print this, and we don't need to print this, and clear. We don't have any segmentation faults now. Now that we have our paths that we can work on is the way we want it to work without causing any problems. We will check this path. Okay, let's add quick error checking after this. If path equals null, which would mean we had problem str duplicating, we will want to print an error saying strdup, and we will return null in case of if we cannot duplicate the path. But now that we have the path, we can work on tokenizing the directories. I would say we can finally tokenize the path and split path into individual directories, this using double dots, because if you remember when we call env, let's be more precise, env echo dot path, between each directories there's double dots, and we will tokenize using these double dots, and that way we can access the directories and check if they are what we are looking for. We already had our token, don't need to code for it now, and the token will be str token function that we will give it the path, and the delimiter we want to check. Again, at this point I even hate it myself, but I'm sure you also hate it. We will implement our own str token so we can stay unique, and it will be returning a char. I will collect my str token, which will receive a char string. I'll just call it str, and inside of that we will check for char delimiter. I will quickly implement our str token. I will first put this in our header file, and let me see, this will be a constant actually, so let's keep things consistent. Const char delimiter, and we will have a static variable called next token. It will be null for beginning. This will point to the next token that we will need. If input string is null, let's name this better also, the input string if input string is null, we will continue from the last token. So if input string equals null, it will be the next token. If there is no more tokens, which will mean the input string is null, we will return null. So same as this. If it is null, we will return null, and we will skip deleting parameters. So let's say while input string and my str character, that will check for delimiter, and the input string plus plus, and of course we will need to have our my_str character function. It will return char my_str character, which will have constant char str and char c, which what it will be looking for, while str exists, and if the pointer to string we are looking for equals the character, we will return that point at the string, so char string. If not, we will increment the string, and if it doesn't work, we will return null. While str and consistent. So why now we are checking the string, the character in our string, which will be delimiter and input string. That we will move on. And if the input string ends after skipping delimiters, we will return null. So we will check for if input string exists and my str character. Oops, why did I do that? If input string is an of it, we will have the next token null. Also we will return null, and now we need to mark the start of the token, which we will call char token equals input string, because we already made some changes on input string that we are at the point that we will need to save it into token. and we need to find the end of the token, so we will say while input string and my str character delimiter will be checked in input string, and it will say input string plus plus. This will be if not in the string, which will mean the end of the string, that we will move a step forward, which will be the end of the token. And if we find the delimiter, we will terminate the token and update the next token. So we will say if star input string exists, so we will say input string equal 0, which will mean we are end of the string, and then the next token will be the input string plus 1, so it means we are moving. Else no more tokens after this. That will mean the next token will be null if there's no more token after this. And when we are done, we will just return the token we made. So we have my str token function. We also created my str character. So we can get tokens for our find command in path. Oh. And to go back there, when we split the path into tokens by using double dots, we will have a while loop to check if tokens exist. As long as they are not null, we will be working. We will construct a full path for the comment. That's why we had full path variable here. But before that, I want to check for the tokens we will have. Printf token %s new line token. Let's see if it's working until this point. Terminal make clear my shell. Let's check for which something, and it will give us tokens. Why it gave same token. Oh. I'm not that smart because we forgot that we are calling this in while loop, so of course it will call it forever. Let's say clear. So we are not in a loop yet. token var, and we will have the full path for the comment. That then we will check if the command exists as executable, and then we will move to the next token. So okay, we are making progress. Now we need to get the full path and work on it. We don't need this for the moment. Let's construct full path. We will use setenv function, which is in, if I remember correctly, in strdo.h header. Now this will have the full path. It will have the size of the full path. As you can see, it says you do. It shows you which inputs, which variables it will have. We will give it the full path. We want to save the path. The size of the full path, we will give it two string variables, which will be our token and command. This will check that we will get full path. We will check if the command exists as executable. For example, when we say which ls, we know it's real, but when I say which something random, it's not real, and I was almost scared. Okay. For that, there's an function called access. See, it's in unistd header. It is checking if the file is accessible or not. That's how we will know if it's real or not. So we will give it the full path, and it wants int amount. Amount is either bitwise increase or the we checked, which will be for x square even after. Okay, we will use x. Okay. Here's our int amount. Read, write, and x. Okay. Let's give it x. Okay. If access is x. Okay. 0 means we are accessing. In that case, we will need to free the path we were on that we duplicated, and we will return my strdup full path, which will return the found commands path. Okay, then we will need to free this after when we return back to the which function, but if the path exists, we will return the full path we found. And after, we will move to the next token, my str token. It will have null and double dots as input, and it will move to the next directory. And when we are done, we will free the path after searching all directories if we want to return the found one, and then we will return null if we didn't find the command. I think this should be all for our find command in path. And when we go back to which, now we will check external comments. Let's go back where we were. This print statement, and the char full path will be find command in path that we will return if we successfully find the full path. And of course, when we declare this, we should not forget that we need to free it when we are done. So I will say if full path is not null, we will printf %s and new line the full path that we found, and we will free it to malloc, and then we can return 0 successfully. Else, if the full path is null, we will say printf which command not found. It can display the command we couldn't find, so it will be args 1 because we are working on it, and it will return 1 saying we failed. And we don't need this, I would say make my shell the moment of truth, and I say which ls command not found. And this is not supposed to happen. And this is because of this. Let's say make again my shell which ls command not found, which means we are not getting the path we are looking for. That will be full path. Make my shell which ls path is null, which means we are not getting the path from the find command in path, which means we know we tokenized the path into dots. So in that case, why I'm returning null? Let's check quickly if there was something we were missing. And while token is not null, we will construct the full path. We will use setenv that we will have the full path using our token and comment, and we will check if we are accessing, if we can access the full path using executable, and if we access, we will return the full path of the comment, and then we will move on to the next token. So I want to put the full path here. See, there's a problem. Make Marshall which ls. It's nice, we are getting the full path in our while loop. But we cannot find the comment we are looking for. Oh, I see the problem. Because we are looking for, so when you see, as you can see, when we say this, it says user bin ls, but what we are looking is not to, we need a backslash before we have our comment. So this will be an easy fix, I would say. Okay, now we see the problem, we can fix it quickly. Basically, after collect the token, we will make sure there is a backslash between the directories, so we can look for the correct directory and access it. So in the while loop, I will make directory works with, starts with, directory ends with backslash, so that we can look for the executable in the directory. So we will say size t len equals my str len of the token, and if token len -1, if the last character of the token is not equal to backslash, we will get this setenv, and then we will have all else, again the same one, but let's got this, construct the full path, check for backslash, and between the and backslash, we will have I hope this should work. Make my shell which ls, and yes, it's working finally. In this case, which cd, it's a built-in command. Let's again make my shell which ls which cat. Perfect. We can find the path in environment, and we can check for the directory and find the executable using which. So in this video we implemented command cd, pwd, echo, environment, which, and we added some helpers. And on the next video we will do commands setenv and unsetenv. And if we looked our to-do list, after that we can start executing external commands. And thank you for watching, and see you on the next part.